Hello and welcome to the section 3.2 lecture today for our Bridges Geometry class. Today we're going to go ahead and start looking at some more transformations in the coordinate plane. So everything we're really working with here has to do with points being moved. And today we're going to talk about reflections. So reflections are kind of what we think of reflections in the real world, where we think about, our reflection in a mirror. It's a little bit difficult to think about, but since it's really a three-dimensional projection onto a two-dimensional surface, it creates illusions that make us think different things rather than actually showing us three dimensions, which is always kind of a tricky idea to think about. But essentially in a mirror, the things that are closer to the mirror at least look closer in the mirror. Things that are closer to the mirror look closer in the mirror. And that same thing happens in geometric reflections. Essentially, what I want to think about doing is taking anything, and for these examples, we do have a line segment that goes through or has endpoints. It looks like 4, 1 and 7, 3. If I want to reflect that across the x-axis, or you'll see a lot of times a written reflection in the x-axis, I probably think about it as flipping over the x-axis a little bit more. But you notice you've got A that's a little bit closer to the mirror, and so A prime ends up a little closer to the mirror. Conversely, B is a little bit farther away from the mirror, and B prime ends up a little bit farther away from the mirror. Sort of an easy way to think about it is if I want to reflect A, it's 1 unit away from the x-axis, so I'll go 1 unit in the opposite direction and get to my A prime right here. B is 3 units away, so I just count down 1, 2, 3, and then I'll count 3 the other way, 1, 2, 3, to give me B prime down here at 7, negative 3. When it comes to sort of a way to adjust the coordinates, because I do look at 2 different ways to do any of these. You can either think about how to visually flip those points or the segment itself, or I can think about what happens to the coordinates. What happens to the coordinates x, y, any x comma y coordinate point is going to change into x and then the opposite of y, or we'll say negative y. Negative y is kind of not correct because if it was already a negative coordinate, it would then move to a positive coordinate. Okay, and we see that happen in this second one where we're reflecting across the y-axis. They say that xy turns into negative xy. And we notice here that x is negative on both these points, or sorry, it's going this way, so they are positive. We don't really see it happen. But if we wanted to flip a point that was negative, and that's the coordinate that's supposed to change to being the negative or its opposite, then it would just turn into positive. So think about these negative signs here as really just saying the opposite, rather than thinking about it saying negative. Okay, for that one and this one over here. It makes it a little bit easier to work with. But I guess looking at this one too, we're reflecting across or flipping over or looking at the reflection in the y-axis. Those are all the same way to say or different ways to say the same thing. So here A is at 2, 3, meaning that A is 2 units away from the y-axis, so we go 2 units the other way and we get to negative 2. B is at 6, negative 4, so it's 6 units away, so 1, 2, 3, 4, 5, 6. gets us to the y-axis, and then 6 more gets us to where the reflection would be. The biggest thing we see with a reflection that we didn't see with the translation is a change in the orientation of the object. In a translation, when we just move something, and I'm going to pick on this one for now, when we just move something somewhere, you would kind of say with a line segment that the slope sort of remains the same, right? This is going up and to the right, and it stays going up and to the right. When we reflect something, when we take it down here, we've actually changed it from going up to the right to going down to the right. Okay, so it's changed its orientation, and this is the first one that does that. Okay, let's look at a couple examples, because I feel like examples kind of drive how to do this. The one thing I always want to make sure that I kind of highlight when I'm doing any of these is I'm going to highlight where my mirror is. So it's given to me in the problem, reflection across the x-axis. So the x-axis is my mirror. And I'm just going to do it point by point. I feel like working with the points is a little bit easier than working with maybe line segments or even the whole shape. Those are both other ways that I could do it, but it's a little bit easier to adjust point by point. So Q is 3 units away. I'm going to go 3 units in the opposite direction, and that's where Q prime is going to live. Let's go with R. R is 5 units away. So I go 5 units the other way, and I get R prime. S is 3 units away. We go 3 units the other way, and that gives us S prime. And that's a very, I'm going to say, more simple way to do a reflection rather than looking deep into the coordinates and what happens there. Now for the next one, I will go ahead and look at the coordinates because it is another way that you can do it. And I'll look at adjusting the coordinates based on what we want to do. There is kind of a trick to using the coordinate rule in reflections. So this one, I want to reflect it across the x-axis yet again. So this is where my mirror is. And it's important to note where that is. Don't get the wrong one and do everything right for the wrong direction. Let's start here with I, and we'll kind of work our way backwards, I guess. I've got I at -5, 2. I'll just get all the coordinates out here. H is at -5, 4. G is at -2, 5. And F is at 0, 4. Here's the trick with reflections and coordinates. If I want to reflect it across the x-axis, it's the y-coordinate that changes. So there's kind of an opposite nature to that. If I want to reflect across the x-axis, the y-coordinate changes. And it just changes to its opposite. So if we look at I, it's going to go from -5, 2. I'm going to change the y-coordinate to -2. So -5, -2 is right here, and that would be I prime. -5, 4 is going to turn into -5, -4 for H prime. -2, 5 will turn into -2, -5 right here for G prime. And 0, 4 will turn into 0, -4. That's right here for F prime. I've got my points. I can go ahead and try to make them look like a closed shape like they gave me before, but I had 2 sides going a really bad direction for me writing. I don't do good with these ones going this way, as we can tell. And that's it. Okay, so that's both the kind of physical move of the points on this one and the coordinate move the coordinate adjustment over here. Pick your favorite way and do this one. Okay, you should get that we're reflecting across the x-axis, and you should get something that looks like this. I'm just going to do it quick and not really talk through it. I want you to come up with a way that you see those points moving to there. And the tricky part here is that that is T and not S. Okay. All right. Moving on to the next couple. These ones were reflecting across the y-axis now, so I'll take a look at doing those in both those different ways. Both physically moving the coordinates and then looking at the kind of the coordinate rule as well. So this one, L is the closest point. It's 1 unit away from the mirror, so I move 1 unit the other way and I get L prime. M is 3 units away, so I go 3 units away and put M prime. J is 4 units away, so I'll go 4 units for J prime. And K is 4 units away, so on the same line, move 4 units the other way for K prime. I'll look at the coordinates on this one and see how to adjust them to get my reflection. So W, I don't know why I start with W, but that's okay, is at, looks like -4, 3. X is at -4, -1. And V is at -2, +3. So remember, when dealing with reflections and coordinates, if you want to reflect across the y-axis, it's going to be the x-coordinate that changes. It's going to change to its opposite. So here we really see that idea of saying negative might not be the best, where opposite might be better. Let's go ahead and start with W. W moving from -4, -3 will turn into the opposite of -4, which is +4. And I think I said -3 for this. It is +3. So +4, +3. So this is where W prime will move. X is at -4, -1. It'll turn into 4, -1, the opposite of -4. And V from -2, 3 will turn into 2, 3. I've got my 3 points reflected, and I can draw my figure. Go ahead and do your best on this last one. Pick one of the ways that I've talked about, either moving point by point or the coordinates. Either one is okay. This one gets kind of weird because it's something that we can't really do in the mirror world of things. This shape kind of goes through the mirror, and that's why I don't typically focus on the mirror analogy. I really think about flipping it over. As an object, I'm going to flip it over. And if you were in class, one thing we did is we put a transparency sheet over this, copied it down, and then we were able to physically flip the transparency and line up the y-axis and see where it ended up. So the weird thing about this in the mirror sense is that X is going to move technically to the left, while Y and Z both move to the right, which in reflections, that's okay. That can happen when your object is laying on top of the line that's being flipped over. So you'd get a shape that looks like this. But again, find Find whichever validation you can think of, whether you like the point-by-point move or the coordinate adjustment. Anyways, that is reflections. Hope you got something out of that. If you have any questions, make sure you ask me. Otherwise, have a great day, and we'll see you in class.